Hello, we're going to discuss hydrates. And so if you are hydrating, that means you are drinking water. So a hydrate is going to have water incorporated into the ionic compound. So a hydrate is a compound that has water trapped in the crystal structure. So these crystals are going to form like cubes or hollow. And so the water will actually be inside of that cubic cell. There's going to be a specific number of water molecules attached to the hydrate. And we're going to write a hydrate with the ionic compound first. And then the second part is going to tell you how many water molecules are there using a prefix. So if you don't remember your prefixes, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So you're going to have the name of the ionic compound and then tetrahydrate. So if there's 4 waters, it would be tetrahydrate. The forces holding these water molecules inside of the salt are not very strong, so it usually doesn't take a whole lot of energy to remove the water. Just a little bit of heat will usually remove it. Some hydrated salts are going to absorb or remove water from the air and form a higher hydrate, and they are called hygroscopic. So they're going to absorb water, and they would go from like a dihydrate to a trihydrate. Hygroscopic compounds are used as drying agents or desiccants. So if you get a new pair of shoes or a new bag, you'll often find that little packet that says do not eat. That is silica gel, and it absorbs moisture during shipping to prevent mold growing on your items. Hygroscopic compounds that remove enough moisture from the air to actually dissolve and form a solution are called deliquescent. So if you have table salt, you sprinkle some on your table on a really humid day, let it sit there for a while, you'll come back and you'll notice that there's no droplets of water where those salt crystals are. Let them sit there longer, and as the humidity drops, you'll see them turn back into a salt crystal. So they're going to absorb enough moisture to the air to dissolve themselves.
May I have your attention, please? All students who are participating in the Black History program, please report to room B260, Mr. Black's class at this time. Thank you.
If you have an anhydrous compound that has no water in it, anhydrous means that there is no water. If you have a dehydrated compound, that means that at one time there was water, but it has been removed. So you took out the water, you dehydrated it. So an example of a hydrate, CuSO4, 5H2O. Now this dot is not a multiplication sign. It is telling you that what is about to follow is actually incorporated in the molecule. So CuSO4, Cu is copper, and we know that sulfate always forms a 2 negative charge. So this copper, if we only have one of them, has to also be a 2 negative charge. So this is copper 2. And then SO4 is sulfate. 5 means penta. And since there is water, like all of these, it's going to end in hydrate. So copper 2 sulfate, pentahydrate. Here we have BaCl2, 2H2O. So Ba is barium. And then Cl is chloride. 2 if you need to calculate the percent of water in the hydrate, you are going to take the mass of the water that is present in the compound divided by the mass of the hydrate. So you're going to use the subscripts to figure out how many of each atom you have, and then you're going to use the periodic table to figure out the mass. You're going to multiply the mass of the atom times the number of atoms, and then you add them all up, and that gives you the mass of your compound. So, let's find the percent water in sodium carbonate decahydrate. First thing we have to do is we have to write the formula for this compound. So sodium is Na plus 1, and carbonate is CO3 with a 2 negative. So if we do our crisscross method, this means that we're going to have 2 sodium. And since this is an understood 1, we're going to have 1 carbonate group. Deca means 10, and hydrate means water. So that's our formula for our compound right here. Na2CO3, 10H2O. So to find your percent water, it's going to be the mass of the water in the compound divided by the mass of the compound. And we're going to multiply by 100 to get a percent. So first atom that we have is sodium. And sodium weighs 23. And how many sodiums do we have? We have 2 sodiums, so we're going to multiply that by 2. Next is carbon. Carbon weighs 12. And we have 1 carbon here. There's no subscript, so it's just 1. Next is oxygen. We have 3 of those. So oxygen weighs 16 times 3. And then for the water, each hydrogen weighs 1, and we have 2 of them here. Oxygen, we said weighs 16, and we have 1. So this is 2, 16. So water is always going to weigh 18. And here we have 10 waters. So we multiply this by 10. So that means that the water in this compound weighs 180 grams. Fine. So in our numerator, it gets 180. In the denominator, you're going to do the ionic part plus the water. So 3 times 2, 46, 12, 48. And add these up. That gives you 106. Now this is the ionic part. To get the whole entire hydrate, you're going to have to add the water that you found over here. So that gives us 286 grams for the whole entire compound. And then we're going to multiply by 100 to get a percent. So 180 divided by 286 times 100 gives you, and you can take it 1 decimal point if you want, 62.9%. So this compound is 62.9% water.